features here actually represented by presenting the devices to guests, which emulate the physical devices available for the physical platform. The good things about this, you don't have to modify anything. Just run the unmodified kernel, drivers should work. That costs performance and functionality. Paravirtualize at the same time, it's simpler to implement, but needs significant modification. And as you can see, there is a hardware here in the green color, and it means it's good because we have some hardware-supported features by processors. And if we use it, we gain performance and security. So for paravirtualized guests, you probably know about the limitations. We're using the MMU PVOps, which are, well, it means every single page table change will have to bounce back to Xen hypervisor. Also, the slow 64-bit system calls, and that's being caused caused by changes in the AMD64 architecture some time ago, due to eliminating of segment limits, which was used as additional protection level for Xen, and developers were forced to use to move PV kernel to the ring 3 for 64-bit, and then it appears that now PV kernel and the user space run in the same ring. Now, that additional protection, which is still required, was provided by, again, going back to hypervisor and on every system call for 64 bits. Also, PV, well, as I mentioned, the PV 64-bit kernel runs in the CPL3. You need to bounce back for system calls and context switch. And also there is a big feature, some of you heard about this. The X86 Linux maintainers are not happy with PVOps. They've been criticizing, and yeah, I understand. It doesn't follow the X86 semantics. It impacts the bare metal code. People don't know, not aware of features. They change the code and it breaks everything. Well, it's bad. All right. So, just some few words about PVOps and what they are, if somebody doesn't know. It's just a Linux kernel basically facility which allows for binary patching of native low-level instructions during runtime. So, if the paravirtualized guest runs under Xen, they converted some of the low operations will be converted into the function pointers, and they will be they will be replaced during runtime with Xen versions of operations. So this is an example of CPU-AD. Well, I think it's a bad example, considering the last discussions of CPU-AD and filtering, but still, this is one of the examples. Well, so now what about the Hvm limitation? So I actually put here Pvh driven by the idea that right now probably everybody uses Pvh instead of Hvm. But still, let's keep in mind it's Hvm. So what are the disadvantages of Hvm? Well, first of all, it runs QEMU, it's slow and imposes security risks. Provides solo simulated devices, which is great, but also, QEMU runs in DOM0 in user space, which requires lots of context switching, and, well, it can run in Minios as well. Also, Hvm has a legacy boot, emulated firmware, and some devices should be emulated as a PCI bus. So, in taking these all good features of PV and Hvm, this is a receipt for Pvh. That's just completely disable emulation, run in CPL0, so we get rid of slow 64-bit system calls. Let's also disable PVOps paths whenever it's possible, and use maybe some limited amount of Hvm hypercalls. And we have a faster, better guest. All right, so disabling QEMU will actually reduce the security risks, improve performance, and uh, will let us avoid the different security vulnerabilities as lately Venom, and you heard probably about the QEMU talk. Yep.
I think it's essential for looking at stuff zero, right? Because you wouldn't have any QEMU when looking at zero.
Right. Right. So also for Pvh, the Xen manages its own page tables. Oh, I'm sorry. It does. Xen manages P2M page tables, and Guest manages its own page tables, which is good, and uses native paging operations. Uses HVM hybrid calls, which I mentioned, and well, we've been discussing lately the special application processor bootings, and I think the additional CPUs will be using the PV path for this. Well, there will be no BIOS and no firmware. The Pvh is putting in the 32-bit mode and no paging enabled. That means we don't have to decide in runtime. We don't have to know which bitness will be the kernel. So we can actually run it on 32-bit and 64-bit. The E820 map will be provided from hypervisor. And no MMU PVOps, which is excellent. Native paging. No hypercalls for changing LDTs, GDTs, and control registers. CPU ID will run native, provided some filtering. Well, it runs in CPL 0. So the Pvh and Linux, right? So what we're gonna, tons of PVOps will be disabled, as I mentioned. Low-level calls will be following the ISA X86 semantics, which will make happy X86 Linux maintainers. Guest will be in charge of its own page tables, and we're going to be using the TLB flush others PV hypercall for performance features. Also, there will be no PV IDT, no PV IRQ. Well, no CPU ID as a par virtualized version will also be absent. No special page tables protections, no page tables pinning, so all that gone, which is nice. So let's take a look at the management of memory subsystem for PV and Pvh. If PV guest is aware of a virtualized environment it's running on and manage its own P2M table, and the guest page tables, the modification of guest page tables has to be assisted by Xen. For Pvh, the situation is different. So if you were going to use the extended page tables or nested page tables from Intel or AMD respectively, we have basically providing combined mapping of linear guest address to physical machine address. So the P2M page tables will be walked the same way, just provided the correct value in the CR3 register to P2M in Xen hypervisor. And they will be walking hardware. Of course, there is a cost of TLB miss, and that's pretty expensive for when using EPT or NPT page tables. But it definitely, it's different. So now let's take a look on the I/O path for HVM and Pvh. Well, in this slide, you're going to see that actually that QEMU runs in the main zero user space, and which requires a context switch between the kernel and the main and QEMU. So when the main guest domain issues some I/O request, the VM exit happens, bounces to Xen hypervisor. Xen analyzes and decodes the VM exit code, passes the control to DUM0. DUM0 analyzes, well, when QEMU gets scheduled, it analyzes how it can emulate the instruction, and then processes all that, presents the result, then control is being returned back to DUM0 and then to DUM guest. So that's a pretty lengthy path. For Pvh and for PV, it's actually the same picture. So it's going to be essentially the same path. It's going to work faster. It's going to use the split device driver model. and going to use the event channels and IO rings for communication. So what are the advantages and disadvantages of Pvh? Well, it's faster. It's small security impact, providing that we're getting rid of QEMU. The bad things, it only works on Linux, FreeBSD, and Mini OS. And legacy deployment will not be able to start this kind of guest. Well, I run a couple of performance tests, and using actually the classic Pvh model, Mukesh, aka. So if you want to, so some of the results actually do not make sense to me yet. So there will be some work done to analyze why it happens, because on some of the benchmarks, the HVM demonstrates a faster response than Pvh, which is not fully understood yet, but there probably will be time for this.
Intel makes really good CPU.
Well, what's the future of Pvh? On the recent, I think the recent technical call which we had a couple of weeks ago actually aligned the future tasks for that and assigned developers who will be responsible for that. The hypervisor part will be basically done by Roger, and Boris will be taking care of Linux. I'll be working on some bits and parts, some bugs, AMD-related stuff. So what should be done to actually have it out of experimental and make people use it? Cpuid filtering. Cpuid. All right. Well, we're going to run the native Cpuid operation on the Pvh. DOM0 support, missing some bits. They will be requiring IOMMU. There is some work for AMD on this, and I'll be working on the TC scaling for AMD CPUs, and that will provide us with absence of Hvm exits on RDTSC instruction, so we don't have to recalculate the frequency in hypervisor, and we just can provide some scalar and MSR, and guest will read it without Hvm exits. MMIO accelerators, which is another part, because right now the Pvh guest is being built as HVM, and it uses old MMIO accelerators paths, which they demonstrate suboptimal performance. And there's been discussion going on in the Xendevel list. I think we have some understanding how it should be done, but that might be changed as well. Who knows? PCI pass-through also requires some work. And of course, bug fixes. Maybe will be the time for shadow paging.
That already works.
Yeah.
Yeah, Roger checked on his latest set of patches. Oh, that's...
Migration works too, right?
Yeah.
Yeah, okay, yeah. All right. All right, so that's good. Awesome. Almost done. I think this project has a good rebranding, and I think I agree with this. Oh yeah, I didn't mention the HVM instance construction, which cumbersome code should be changed a little bit, because the DOM0 construction code right now, it's pretty big and confusing. So if we're gonna come up with a new beautiful code which will construct the domains Pvh or HVM, that'll be awesome. What the current status is, we actually probably think there's a common understanding that we came with a split kind of model, or based on timeline, the classic Pvh and light HVM or no DM. I mentioned that Roger Pau and Boris Ostrovsky will be working in this. So I think, well, yeah, I think that's it. That's the status of the Pvh as of now. So tomorrow we're going to have Birds of Feathers talk. Some people are missing. And yeah, you're welcome to ask questions if you have any. If you're not too tired. No questions. Yeah, go ahead.
So how are you going to build HVM without full stack? Especially what are you going to do with SandStorm, for example? I understand why you need that. 1.0 Pvh. Like, how are you going to do that?
All you, that bit's only referring to how you construct DOM0. Once DOM0 boots up, it starts XPDS15.
Oh yeah, that's.
Yeah, I mean, but
That's
now...
not on TV.
Yeah, I was like thinking about that you'll need some modifications to HVM, Linux part of HVM. Because right now when it starts, first thing it does, it tries to access and store. And if it fails,
you don't need any modification. We are using a bit the same thing on our not Pvh, but with basically we don't have any issue just on that because it's the DOM0. DOM0 is putting us with the hardware kind of HVM.
So, literally, Vitaly, you were thinking that you would be using a normal HVM boot path with firmware and boots up as a normal Linux sketch, right? Yeah, so we can't do that because we don't have a CBIOS, nor any BIOS to speak of.
just to code how this part of Linux kernel looks, this early boot for PVHVM gets.
Right, so the PVH, so Boris has been he hacked it a little bit, took a provider code. What he ended up doing is, we have this one, there's an ELF node that says this is where you should start executing. And in that code path, you put it with the FreeBSD code path, which sets up page tables, sets up page tables, switches to 64-bit mode, and then the next thing would actually jump straight into start underscore x86, or start i3, one of those, which is the native boot path that a bootloader on Linux would do. And then of course we ran into the problems that the Linux kernel expects the bootloader to provide struct boot params, which has a whole bunch of Linux-specific stuff, and we didn't provide that, so it boots up with no command line, nothing of that kind of technical.
Now, with just another the hypervisor.
Yeah, well then you have this issue that now you're providing Linux-specific boot lead. Yeah, but FreeBSD doesn't have that, right? So we got to figure out that particular path. And part of it is we already do this via HVM params. Sorry, we do that via HVM params.
Some feature sets.
And then does then start it so we can. Oh wait, multi-boot.
Yeah, multi-boot.
So there's a whole bunch of things that we can. Linux code path and boot path can take that and squash it into this boot param so that it boots with what it expects. And that's feasible. That's the next part. So to come back to your question, it is kind of a hybrid because we have the stub code that loads, sets up the right thing, and it executes the Linux code in the same point of bootloader would do, with all the things that it expects.
Then we won't have any bootloader. I mean,
Well,
oh,
the stub is a bootloader. That's the point. It just happens to be the Zen bootloader that's a couple of lines of assembly.
Right. So we just utilize that, which works great. I mean, it's basically using that to work, well, whatever the x86 from .txt defines, that's where we're executing structure. So Elena pointed out to the x86 containers, this is the neat thing is that we now start the big vision of the world as if you normally bare metal.
No, it's been addressed as a possible suggestion.
To the x86 containers?
They
Well,
don't need to know.
They don't need to
No, really.
So
They don't need to know.
The Linux con is, I hope to see Peter and Thomas and talk to them about it. But I mean, that's,
I mean, to me, it sounds great.
we did talk about it 2 or 3 years ago, and they were all for it. So I don't think there's any.
We would actually solve tons of issues with it.
Right, there were tons of issues you're looking at, but also solve some of their issues that they're hitting as they have to maintain the code. So, like, there's some semantics, for example, set PTE that are different on bare metal and Zen keyboard. And we know about it. And whenever x86 maintainers write it, if they copied us, then develop, we could fix it. And that's what we've been doing. Boris has been working with them, Ostrovsky. Whenever they hit something upstream aggression, he jumps on and helps them to troubleshoot. We're better if it was CC. But anyhow, point being is, now this problem will disappear magically.
That's the discussion has to kick off, but there's some.
Well, it has kicked off. We chatted this in the past, that this is what we'll do. And both Peter and Thomas were CC'd on that. It's just that it's been slow moving.
Hey, it seems like something worth working on. So.
Oh yeah, no, fantastic. I mean,
I'd love to see that, and I
oh, perfect. Not a victim.
No, I mean, I really think it's.
Hold on, let me put your name here.
It's Lucas.
So, more of a point than anything else. From the technical discussion that we had a couple of weeks ago, we do have a plan for 4.7 to get basic DOM use working. And it's fantastic. We actually have an idea of what we're going to do before a release starts rather than at the end and scrabbling around for features. But yes, so there is a plan and some people have some work. So with any luck, we should have plain DOM-U, no frills attached, Pvh working for Zen 4.7, unless something goes very wrong.
No PCI pass-through, right?
No,
Yeah, that PCI pass-through is just frills. that can come in V2.
All right.
all right.
All right. Thank you.